Greetings everyone, and welcome to Multiplying and Dividing with Significant Figures. So yesterday we saw how to keep the right precision when we are adding and subtracting. So today we're going to develop rules that will help us do the same with multiplying and dividing. So here's our first of three little example problems. What is the area of a rectangle with sides of length 201 meters and 1.4 meters? Well, of course, to find the area of a rectangle, you do length times width. So we have 201 meters times 1.4 meters. Now I've turned the last digit into red because those are the estimated digits in our measurements, remember. So 201 is estimated to the nearest 1. 1.4 is estimated to the nearest tenth of a meter. Now, kind of like we did with addition here, we're going to follow through the multiplication here step by step. And things that are affected by red numbers are going to be turned red because they're contaminated by the estimation part of this. Right? So 201, we start out with 201 times the 4. And since the 4 is going to multiply by each of these, it's going to turn everything red, and that would, of course, be 804. Then we're going to put in a 0 down here and then multiply 201 by 1. And if you notice, since the 1 is black, when it multiplies by the 1, that'll be red, but the 0 and the 2 times 1 will stay black. So if we add these up, and we'll get 2,814, and then we have to do units, meters times meters, meters squared. So we have 281.4 meters squared. Our question now is, where should we round up so we keep the right precision in our answer? Well, like we did with addition and subtraction, we're going to use our basic idea here of what is a sig fig, everything we're sure of, plus one estimated digit. So if you look at the number 281.4, our first estimated digit, or our first one that we can then estimate, is the 8 in the tens place. So we're going to round this off to the nearest 10. And 281.4 meters squared to the nearest 10 is 280 meters squared. Notice no decimal point, so that 0 does not count. It's a placeholder, so this is precise to the nearest 10. Now again, this may look like you're getting rid of a lot of good data, but you're not. What you're getting rid of are numbers in the measurement that you're not sure of. And so we're trying to keep that down to just one estimated digit. Now, what about a more general rule here? Well, let's check out the number of significant figures in each original measurement and compare that to our answer. So 201 meters has 3 sig figs. The 0 counts because it's bounded. 1.4, of course, has 2 sig figs. And look at our answer. Our answer only has 2 sig figs, just like the least number of sig figs in our original measurements. So the answer has only 2 significant figures, the least number in our original measurements. So is that the rule? Well, let's do another example and check. What's the area of a rectangle with sides of length 21 meters and 4 meters? Well, we multiply, and again, the 1 and the 4 is the estimated. Since this one only has one digit, the whole number is estimated. So when we multiply, we get 84 meters squared. And if we can only keep what we're sure of plus one estimated digit here, we're not sure of anything. So we can only keep, at best, one estimated digit. So 84 rounded off to one estimated digit is 80. Again, no decimal point, so the 0 doesn't count. Meters squared. So let's now look at the number of sig figs. We have 21 has 2, 4 only has 1, and look at our answer. Only 1 sig fig. So it looks like our answer should have the least number of sig figs in our original measurement. And that's going to be our general rule here. So, rules for multiplying and dividing. Step 1, multiply or divide. Show what you have here on the calculator. And then round the answer to the least number of significant figures in any measurement. Notice this is completely different from what we did with addition and subtraction. Addition and subtraction was the least precise number. Multiplication and division is the least number of sig figs. So they're different things that we have to do, and it's because of the way multiplication works versus the way addition and subtraction are columns. Okay, so let's try one more example with this set of rules now. Let's just take some random 32.0 meters per second divided by 16 seconds. Why are we dividing these things? We'll have problems like this later on in the year. For now, let's just do it as an exercise. So the first step says multiply or divide. I hope you can divide 32.0 by 16. Of course, the calculator would give us 2. But the question then is, where do we round off? Well, we round the answer to the least number of significant figures in any measurement. Well, in the 32.0, the 0 counts because it's after a non-zero digit, and there's a decimal point. That's rule 3. So there are 3 sig figs in 32.0. There are, of course, only 2 sig figs in 16. So according to this rule, then, we need to have 2 sig figs in our answer. And right now, we only have 1. This is a case where the calculator actually gets rid of good precision. It overrounds, if you will. All right, so the calculator is getting rid of precision we want to keep in our answer. So if we want to write 2 to 2 sig figs, we'd have to add in a 0.0. That 0 would count because it's after the non-zero digit and there's a decimal point, the ever-popular Rule 3. So this is a kind of an interesting case because in this case the calculator overrounded, but our sig fig rules gets us back to the correct precision in our answer, the correct number of sig figs. So let's handle the units now, because these are kind of a weird set of units that we'll see later on in the year. We have meters per second over seconds. Now the first thing you have to understand is what this horizontal line means. It of course means to divide. So we can rewrite this as meters per second divided by seconds. But dividing by a number is the same as multiplying by its reciprocal. Remember that from math class. And the reciprocal of seconds is 1 over seconds. So meters per second divided by seconds is the same as a meter per second times 1 over a second. And now we can see what the units will be. Meters times 1 would be meters. Seconds times seconds would be seconds squared. So this is a meter per second squared. And this only shows up when we get this combination and we have a division. And not a multiplication. That's going to cancel differently. But in this case, we get units of meters per second squared. So there is our answer using our new rules for multiplying and dividing with significant figures.